Hey, here we go. Finding some areas of quadrilaterals, and this is going to have some triangles on it as well. All right. Area formulas. The area of a square is the square of the length of its side. If I have a little picture of a square here, all four sides equal. And if this is x, they're all x. Area is equal to x squared. Some people write it as s squared. This postulate 25 is just a side postulate. If two polygons are congruent, then they have the same area. Area addition postulate. This one's a little bit more prevalent. We're going to use it for some non-normal shapes where we can break the shapes into some different shapes. The area of a region is the sum of the areas of its non-overlapping parts. For example, if you're given a shape like this, that had an extra triangle on it, you could find the area of the rectangle and the area of the triangle, and you could add it together. And you could add those together. All right. Area of a rectangle, the product of its base and height. Area is equal to base times height. If you want to draw a sketch off to the side, here's your base, here's your height, you got a rectangle. The one thing to know is that the base and the height are associated by a 90-degree angle. All right, because the next formula is the same, but it's not a rectangle, it's a parallelogram. It's a product again. With a parallelogram, you have a corresponding height, which would be a perpendicular edge, and that relates to the base. Area is equal to base times height. But you have to have the perpendicular height in order to call it the height. It has to be associated with 90 degrees. Area of a triangle. Area of a triangle is half the product of the base and the corresponding height. Half the product. So in a triangle, you have a base, but then you have to have a corresponding height. So it's base times height divided by 2, or 1/2 times b times h, 1/2 bh. So use either version for the area of a triangle, base times height divided by 2. Trapezoid, this one is a unique one, all right? The product, it's got a little bit of triangle in it because it's got 1/2, but you have to add the base lengths together. So in a trapezoid, you have one pair of parallel sides, and you call those base 1 and base 2. So if I have a trapezoid here, and these are parallel, this would be base 1, and down here would be base 2. And you have to have a corresponding height, so you have to have some sort of perpendicular to call your height. But its area is equal to 1/2 times height times base 1 plus base 2. Got to add your bases together. 1/2 h, b1, b2. But the b1, b2 have to be summed together. Rhombuses and kites, they share a formula, and they use diagonals. It's 1/2 the product of the diagonal lengths. If you have some room, you can sketch this kite, and the diagonals go this way, this and this way. All right, this distance from here to here is diagonal 1. This distance from here to here is diagonal 2, so it's 1/2 d1, d2. The diagonals are this length and this length. Works for rhombuses and for kites. So here's a formula. Here's the area of a triangle, area of a parallelogram, area of a rhombus or kite. All right, let's do some of these example problems. So in A1A, it says the base lengths are 8.5 and 11. So this is 8.5 up here, 11 down here. This height here is 4. So the area is going to be 1/2 times 4 times the sum of 8.5 plus 11. 8.5 plus 11 is 19.5. So it's going to be 1/2 times 4 times 19.5. And you can multiply this in any order, but if you multiply these two together first, it would be 2 times 19.5, so it would be 39 centimeters squared. That's the area of that trapezoid. Base 1, base 2, add those together, multiply 1/2 times the height times the sum of the bases. All right, let's do some example problems on page 277. This one's a rectangle. First, identify the shape. If you can't identify the shape, you can't pick the right formula. So it's going to be area is equal to base times height. So we're going to take 7.25 times 2.5. Area is going to be 18.125 inches squared. This one's a triangle. So we're going to do this formula. Area is equal to base times height divided by 2. I'm not going to use the 5. I've got to use the 6 and the 8. So area is going to be 8 times 6 divided by 2, which would be 48 divided by 2. You can do all this stuff on your calculator. 24 centimeters squared. Areas are square units. Next problem is a weird shape. So for this one, you kind of have to count. You just have to count the squares. This is an irrational shape. Count the squares and add them together. This kind of uses the angle addition postulate, or say the area addition postulate. So I'm going to say 1, 2, 3, 4, 5, 6, 7. These two together make 8. Let's see. These two together, half and half, that makes 9. This one down here and this one up here, that makes 10. And I have not accounted for this one, that's another half. And this one up here is actually 3/4. So 8, 9, 10, this would be 11 1/4. 11 1/4 units squared. So that one's kind of a strange one. This one, I'm going to do this one as a parallelogram. So we're going to do area is equal to base times height. So the 39 and the 34 have to associate here. Don't use the 36. Sometimes they'll give you too much information. 1,326 meters squared. This one's a square. Area is equal to x squared, so 15 squared is equal to 225 units squared. This one's a kite. So this diagonal distance is 30. Doesn't matter which one you call D1, which one you call D2. This diagonal this way is 28. So the area is 1/2 of 30 times 28. So you can multiply in any order, but 1/2 times 30 times 28 is 420 units squared. So that's a kite. That's how you do a kite. Use those diagonals. And let's see, a few more problems to finish up here. Trapezoid. This one's a trapezoid. This is B1, this is B2. You ignore the 8, this is your height. So you got to do 1/2 times 6 times 6 plus 14. So B1 and B2, the 1s and 2s are just subscripts, okay? So 1/2 times 6 times 20 would be 1/2 times 120, 60 centimeters squared. This one is a rhombus. Rhombus is just like the one above it, just like a kite. This diagonal would be 30 plus 30, so D1 is 60. This diagonal would be 40 plus 40, that'd be 80. So it's going to be 1/2 times 60 times 80. Be 2,400 meters squared. All right, These last two are irregular shapes. We're going to break them up into some shapes we can work with. So I'm going to break this one here and here. I'm going to do it as 3 rectangles. This rectangle is a 5 by 4 for 20. This rectangle in the middle, we've got to do a little bit of analysis here. This 3 and 4 across the top is 7, so this is only going to be a distance of 2 left to right. And up and down, 5 minus 2, this is going to be 3. Got to kind of analyze the vertical edges. So this one's just going to be 3 times 2 or 6. And then this last one is 6 by 3. 6 by 3. It's going to be 18. Add those bad boys up. 26 plus 18 is 44 centimeters squared. All right, this one's even more strange, but I'd take it and cut it right here. Do this rectangle, which would be 18 times 6. That'd be 108. And then I've got to do this triangle. Now for this triangle, I have to analyze this height. The height would be 9. Area of a triangle is 1/2 times base times height, or base times height divided by 2. So it's going to be 1/2 times, let's see, the base, I see 3, 6, and 18. This base would be 9 across here. 1/2 times 9 times 9, because this height 9 right here is going to match inside the shape. So it's going to be 40.5, 1/2 of 81, 40.5. So your final answer is going to be 108 plus 40.5, so 148.5 centimeters squared. And that's it. All right.